going to study the distance and midpoint formulas. We're going to use the distance formula, use the midpoint formula, and solve word problems. We define the rectangular or Cartesian coordinate system as the plane formed by two number lines, the x-axis and the y-axis intersecting at right angles. Points in the xy plane are located and labeled using ordered pairs x, y, called the coordinates of a point. 4 is the x-coordinates, y is the y-coordinate for this point. The 4 means that on this horizontal axis, which is the x-axis, we move to the right 4 units. The 5 means we move up 5 units. This point, -2, -4, means we move to the left 2 units and down 4 units. These 4 regions in the xy plane are called quadrants, labeled as follows. Quadrant 1, x and y coordinates are both positive. Quadrant 2, the x-coordinate is negative, but the y-coordinate is positive. Quadrant 3, x and y's are both negative. And quadrant 4, x is positive, but y is negative. Notice, above the x-axis, called the upper half plane, the y-coordinates are both positive. The x-coordinates are negative on this side and positive on this side. In this lower half plane, which contains quadrant 3 and 4, the y-coordinates are negative. The distance between any 2 points, x1, y1, and x2, y2, we denote this distance by d, p1, p2, and it's given by the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. For example, find the distance between the points 3, 8, -1, 2. If we allow 3, 8 to be point 1 and -1, 2 to be point 2, then the distance between point 1 and point 2, -1 is x2 minus 3 plus y1 is 2 minus y2, which is 8. -1 minus 3 is -4, quantity squared. 2 minus 8 is -6, quantity squared. 16 plus 36, square root of 52. Well, 52 is the same as 4 times 13. 4 is a perfect square. The midpoint formula. The midpoint xy of the line segment from P1, x1, y1 to the second point, x2, y2, is given by xy, which is x1 plus x2 divided by 2 for the first coordinate, and for the second coordinate, y1 plus y2 divided by 2. Notice this is merely the average of the x-coordinates between the 2 points and the average of the y-coordinates of the y's between the 2 points. For example, if we want to find the midpoint of a line segment between point 1, 3, 8 and point 2, -1, 2, we use this formula. For x1 we have 3 plus x2, which is -1. So 3 plus -1 divided by 2 is 2 divided by 2, which is 1. Now this is the x-coordinate of the midpoint xy. Similarly, for the y-coordinate, we have 8 plus 2 divided by 2, so that's 10 divided by 2, which is 5. So the midpoint is 1, 5. For example, a Dodge Intrepid and a Mack truck leave an intersection at the same time. The Intrepid heads east at an average speed of 30 miles per hour, while the truck heads north at an average speed of 40 miles per hour. Find an expression for their distance d apart in miles at the end of t hours. First, we draw a diagram. Both the Intrepid and the truck have the same beginning point. The Intrepid heads east 30 miles per hour, while the truck heads north 40 miles per hour. We want to find their distance d at any time t. Now, distance equals rate times time. We'll let m equal the distance the Mack traveled, which is 40t. Let I equal the distance the Intrepid traveled, which is 30t. The distance is the square root of m squared plus I squared, which is the square root of 40t quantity squared plus 30t quantity squared. Now notice, this 40t is the same as 4 times 10t quantity squared, and the 30t is the same as 3 times 10t quantity squared. We can factor out the 10t squared from both of these terms. Since multiplication distributes over addition, we can factor out the 10t quantity squared from both of these terms. So we factored out the 10t squared. From this term, we have what's left is 4 squared, plus from this term, what we have left is 3 squared. Since t is positive, and we can take the square root of a square, this term becomes 10t. 4 squared is 16, plus 3 squared, which is 9. So this equals 10t times the square root of 25, which is 10t times 5, or 50t. Therefore, the expression for the distance apart in miles at the end of t hours is 50t.